topic in this video is dividing complex numbers. The first thing that you need to know when you're dividing complex numbers is how to find a complex conjugate. So this might sound like a big word, but it's really pretty simple. The real number stays exactly the same, so the a doesn't change, but the bi, if it was a plus bi, it turns to a minus bi. If it was a minus bi, it turns to a plus bi. So the conjugate is always going to be the opposite one of these. So for example, if I had 2i minus 15, first I'm going to put it in standard form. So I put negative 15 plus 2i, and then like I said, the real number stays the same, so negative 15, and I turn it to the opposite, so minus 2i. And you're going to need these when you're dividing. So let's look at how we actually divide. So it's kind of complicated, but we'll break it down into steps. So you have this problem. So the original problem is the problem in green. So you have 3 plus 7i divided by 8i. So we're trying to divide by 8i. So in order to divide, we have to get rid of this. So we can't leave i's in the denominator, just like we can't leave radicals in the denominator. So in order to get rid of it, we're going to multiply by its conjugate. So the conjugate here, we have 0 plus 8i, so we multiply by 0 minus 8i. And to keep it simple, we'll just write a minus 8i. So we go through, and let's look at the bottom first. So if we talk about the bottom first, if we multiply this, it would give us a negative 64i squared. We know that I squared turns into negative 1, so we end up with a positive 64. Alright, now let's look at the top. We're going to distribute this to both terms, so that gives us a negative 24i and a negative 56i squared. And then we're going to go ahead and know that the I squared turns to a negative 1, and so therefore this becomes a positive 56. And I'm going to go ahead and write it in the correct form of a plus bi, so I'm going to put 56 minus 24i over 64. But the rule has not changed that I need to give my answer in standard form, so I need to give it a plus bi. So here's what I had. I'm going to split it up into two parts. The real part, so the 64 goes under that, and the imaginary part, and the 64 goes under that. But just like always with fractions, I need to see if it can be simplified, and so I was able to simplify this, and I divided both of these by 8 and both of these by 8, and my final answer is 7 over 8 minus 3/8i. Okay, so when I divide this, I end up with 7/8 minus 3/8i. So let's try an example. Okay, so I can't have an I in the denominator, so the way that I divide is that I need to multiply by the conjugate. So to multiply by the conjugate, I make 2 plus 4i. So just like what I do to the denominator, I have to do the same to the numerator. Okay, so now I'm going to go ahead and FOIL here, or you can use a table if you would like. Either one is fine. Alright, so I foiled the top, now I'm going to foil the bottom. Okay, so the first two terms together are going to make 4. Now realize the outside and the inside are going to cancel each other out because I'm going to have, and that's what we want to happen because we definitely want that imaginary number to go away. And then my last two terms are going to give me a negative 16i squared. Okay, so on the top, I know this is going to become a minus 4. So on the top, I'm going to have 6 plus 22i. And then on the bottom, I said those will cancel. And I'm going to end up with 4 plus 16. And I'm going to end up with this as an answer. Okay, now I know I need to split this apart so I can split it up. And I need to make sure it has the real part plus the imaginary part. And then I see if this can be simplified. So I see this can be 3/10 plus 11/10 I. Okay, so I multiply the top and the bottom by the conjugate, and then that is always going to cancel out the i's on the bottom. Multiplying the conjugate cancels it out, so you should always be left with one single number in the denominator, and then you'll be left with a binomial in the numerator once you've combined like terms, and then you got to split it up into a plus bi. Okay, so for those of you who need to see one more example, I'm going to go ahead and do one more example. So if you remember the first step, multiply by the conjugate. So you need to also multiply the top by the conjugate. Alright, so I'm going to do FOIL here. So I'm going to have the first outside, inside, and the last. Okay, now I'm going to do FOIL to the bottom. Okay, so that these are going to cancel. Okay, so I ended up with that. Now, this is actually 6 minus -1, or 6 plus 1, which is going to be 7. And then if I combine those, it's going to be plus I. So the numerator ends up 7 plus I. In the denominator, this is going to be minus -1, or plus 1. And those, of course, are going to cancel. So I end up with 5. Now, I know that if I need a coefficient, I can make a coefficient of 1 here. So that when I split this up, it would be 7/5 plus 1/5 I. So again, I always give my answer in a plus bi.